Assalamualaikum warahmatullahi wabarakatuh. We are from AS120 5K. We'll be presenting lab report for experiment 5, which is gas chromatography. Before we go to the next slide, I would like to introduce to you guys my group members. First, me, Muhammad Dani bin Mazzukanan. Second, we have Muhammad Zuno Ain bin Muhammad Zuraini. Third, we have Muhammad Faris bin Nur Ishaq. And last, we have Muhammad Alif Azril bin Yusmina. Objective of this experiment: first, to determine the retention time of N-butanol and 2-propanol. Second, to identify the components present in a standard mixture based on the retention time. Third, to identify the components present in an unknown sample. And last is to determine the effect of temperature on retention time and resolution. Introduction. Complex compound combinations can be separated via chromatography analysis. Chromatography, which was first utilized in the early 1900s, gained its name from the fact that it was used to separate various mixes of colored substance. As scientists became aware that this experimental method could also be used to separate mixtures of colorless substance in the 1930s, chromatography's use became more widespread. A mobile phase and a stationary phase are the two phases present in every chromatography apparatus. A sample is transported through a solid stationary phase by a liquid or gas known as the mobile phase. Due to variations in the mixture's affinities for the stationary phase and solubilities in the mobile phase, the compounds will separated as the sample in the mobile phase move through the stationary phase. The eluted substance in chromatography analysis are identified by their TR retention durations. Determine TR analyze and compare them to TR standards as part of a qualitative study. Comparing the areas of the analyte peaks with those of standards allows for quantitative analysis. So now, apparatus. First, we have shrink. Second, we have beaker. And last, we also have a dropper. So, the chemicals that we use in these experiments are first, 2-propanol, second, N-butanol, third, standard mixtures of 2-propanol and N-butanol, 1:1 ratio, and last is unknown sample.
Procedure A. Sample handling. First, the syringe was rinsed before being filled with a sample. The syringe was tapped gently to make sure there is no air bubble inside the syringe. Second, the syringe was held vertically, needle up, and the plunger was pushed to the required volume at eye level. The excess sample was removed using the tissues. B. Experimental. First, the instrument was switched on. Second, the gas chromatography was set using the following condition. First, initial oven temperature 70 degrees Celsius. Second, final oven temperature 70 degrees Celsius. Injection temperature 180 degrees Celsius. Lastly, detector temperature 180 Celsius. Third, the component sample was injected and the retention time of each component was determined individually. 4. The standard mixture was injected and each component present was identified by comparing the retention time of each component with the retention time of each single component determined previously. 5. The unknown sample was injected and the component present in the unknown was identified. 6. The column temperature was changed as follows. First, initial column temperature 100 degrees Celsius. Second, final column temperature 100 degrees Celsius. Third, inject the standard mixture and comment on the effect of reducing the temperatures on the retention time and R of the component. 7. The oven temperature was changed as follows. First, initial oven temperature 140 degrees Celsius. Final oven temperature 140 degrees Celsius. Third, inject the standard mixture and comment on the effect of reducing the temperature on the retention time and R's of the component. C. Operation of gas chromatography. First, the sample is manually injected into the septum using syringe. Next, the oven column is checked and the instrument is ensured to be in the off mode before starting. Then, the instrument is switched on. If the gas supply is insufficient, a warning sound will be heard. After that, instrument 1 online is selected on the screen, allowing the instrument to initialize and set up automatically. Once the setup is complete, the method is edited and confirmed by clicking OK. The title of the method is then entered and saved. For in the injection setting, manual mode is selected. The injection location is set at the inlet and the inlet parameter are added and saved. Next, the appropriate injection mode is chosen. Split mode is used for sample with high concentration, while splitless mode is selected for sample with low concentration or small quantities. After that, column number 2 is selected in the column section. Constant pressure mode is applied, and the ambient condition is chosen for the outlet column. Finally, the detector column is selected and the flame ionization detector at the front position is used. All required parameters are then entered to complete the setup. Next, all the enter parameters are confirmed by clicking OK. Then the method is applied and the signal detail are adjusted. Integration event are added and the report format is specified before confirming all settings. After that, the method is saved by going to the File menu and selecting Save Method, ensuring all commands are stored properly. Before injection, the syringe is checked carefully to make sure there are no air bubbles present. Then the Run control window is opened and the sample information is entered, including the operator name. Signal 2 is selected and the sample name is filled in accordingly. Once the instrument is ready, the run method is clicked and the instrument waits for injection. The sample is injected quickly, the start button is pressed immediately, and the syringe is removed promptly from the septum. After the run is complete, data analysis is performed by opening the file and loading the signal. Calibration is then carried out by creating a new calibration table, entering the required detail, and printing the document. Finally, for the next sample, data analysis is selected again, and the same step from 70 to 21 are repeated.
This table shows the retention time of the standard mixture and the individual compound analyzed at the temperature of 7 degrees Celsius. For the standard mixture, two retention time are observed, which are 5.772 minutes and 6.853 minutes. This value represents the presence of two different compounds in the mixture. When I compare this with the individual standard, 2-propanol has a retention time of 5.746 minutes, which is very close to the first peak in the standard mixture. This confirms that the first peak corresponds to 2-propanol. Similarly, N-butanol has a retention time of 6.879 minutes, which closely match the second peak in the standard mixture. This confirms that the second peak corresponds to N-butanol. Overall, the data show that the 2-propanol dilutes early than N-butanol due to its lower molecular weight and high volatility. The standard mixture helps to verify the identity of both compounds based on their retention time. This slide shows the chromatograph for 2-propanol. Only one sharp and tall peak is observed at around 5.7 minutes. The absence of other peaks indicates that 2-propanol is highly pure. The high peak intensity also shows that the compound is present at a high concentration, and the analysis was carried out efficiently. On this slide, we can see the chromatograph for N-butanol. There is a major peak at around 6.6 to 6.8 minutes, which represent N-butanol as the main compound. A small peak appears yearly, indicating the presence of minor impurities. This show that the sample is not completely pure, but the main sharp peak indicate good separation during analysis. This slide show the chromatograph for the standard mixture. Two distant peaks are observed. The height peak at around 5.7 minutes correspond to 2-propanol, while the second peak at around 6.8 minutes correspond to N-butanol. This standard mixture is used as a reference to confirm the identity of the compound in the unknown sample.
So, I will explain the question related to gas chromatography. Gas chromatography is suitable for analyzing gas and volatile compounds that are thermally stable. The flame ionization detector, or FID, is suitable for this analysis because it is highly sensitive to organic compounds and produces clear and sharp peaks. Lastly, two factors that can increase the efficiency of a GC column are column length and column temperature. So we go to discussion. In this experiment, gas chromatography was used to determine the retention times of 2-propanol and N-butanol. At a column temperature of 70 degrees Celsius, 2-propanol show a retention time of 5.749 minutes, while N-butanol show a longer retention time of 6.879 minutes. This occurs because N-butanol has a higher boiling point and interacts more strongly with the stationary phase. The standard mixture chromatogram shows two peaks at 5.772 minutes and 6.853 minutes, which are close to retention time of the pure compound, confirming successful separation. The unknown sample was identified by comparing its retention time with the standard compound. It was also observed that increasing the column temperature reduces retention time but may decrease peak separation. Overall, FID was suitable for this experiment because it is sensitive to organic compounds such as alcohol and produces clear peaks.
In conclusion, gas chromatography was successful used to analyze 2-propanol and N-butanol. 2-propanol had a shorter retention time than N-butanol at 70 Celsius. The standard mixture showed two peaks which matched the individual compounds. Temperature affect the retention time and separation in gas chromatography analysis. This experiment showed that gas chromatography is useful for identifying organic compounds.
So, as we can see, this slide shows the reference for our presentation.
That's all from us. Bye!